This is we're in section 9.2, problem number 9. Find the coordinates of both P and M. Let's start by finding the coordinates of M. All right, so in order to find the coordinates of M, what we want to do is use that midpoint formula that we have. Take a look at it. We have the coordinates of point A and point B. So we go ahead and we set this up by using our midpoint formula. So if you notice, this is the average of the x's, and then we find the average of the y's. X sub 2 plus x sub 1 over 2. Y sub 1 plus y sub 2 over 2. That's the formula. Let's go ahead and do a little bit of substitution. As long as you stay consistent, it doesn't matter which one is x sub 1 and which one is x sub 2. The way it's written here, what we have is we got 3 plus 5 over 2, and then we have 6 plus a negative 2 over 2. That tells us that our midpoint M is at 4, 2. So we found the coordinates of M. Now the only thing left to do is to find the coordinates of P. Now this one is only one. The way we're going to go about it is there's only this is just one way of going about finding the coordinates of P. So let's go ahead and let's do it this way. First thing that we want to do is we want to find the slope of segment AB, or chord AB. Same thing. So let's go ahead and use the slope formula in order to find that. Our slope formula is x sub 2 minus x sub 1, y sub 2 minus x sub y sub 1 over x sub 2 minus x sub 1. Rise over run. Do our substitution. We end up with that the slope of this line is negative 4. Right? Then what we want to do is we want to go ahead and we want to use that negative 4. Remember that what that is as we move forward, because we will use it to find the coordinates of P. So we have that the slope of AB is a negative 4. One thing that you notice is that segment PM is perpendicular to AB. What is the relationship between two lines that are perpendicular in regards to their slope? That's the question that we do want to ask ourselves. So here we go. Let's go ahead and find the slope of segment PM. Well, these two segments are perpendicular. So what we know is that the slope of PM has to be opposite and reciprocal of the slope of AB. Both opposite and reciprocal. So if you take a look at the slope that we had before, that slope was negative. The slope of our line PM has to be positive. Reciprocal, instead of 4 over 1 is going to be 1/4. So now we have our slope. We have the slope of line PM, and we also have the coordinates of point M. So we have the slope and the point. We're going to use those two bits of information to figure out that coordinate of point P. Right. So in order to do that, we do have to come up with a formula. The equation that we want to use is this one here. Y minus y sub 1 is equal to m times the quantity x minus x sub 1. In order to use this formula, we do need a point, which we have. We also need the slope of a line, which we have as well. So let's continue. Let's go ahead and do a little bit of substitution. If we substitute that the slope is 1/4 and the coordinates of M are 4, negative 2, this is what our substitution looks like. Y minus 2 is equal to 1/4 times the quantity x minus 4. And once again, don't let that 1/4 throw you off. Usually fractions tend to throw off students, but in this case, don't let it scare you just because it works out pretty nicely. Here we go. Now we solve. We distribute the 1/4 to everything inside of the parentheses, and then we go ahead and we add 2. That negative 1 came from 1/4 times the negative 4, which is just really negative 4 divided by 4, which is negative 1. And then we continue this a little bit further, combine like terms negative 1 plus 2. We end up with that as our equation. Now, if you recall back to your algebra lives, back when you took algebra, that plus 1, that's considered your y-intercept. Since you know that P is right on the y-axis, we could say, just go ahead and say that, that is your y-intercept. So point P is in fact at 0, 1.